It has already begun. Right now. While you are watching this video, the universe is slowly, but inevitably, moving toward its end. And scientists know exactly how it will destroy everything. Every star, every planet, every atom. But there is one scenario they only talk about in whispers. Because in that one, the end comes without warning, and at the speed of light. Physicists have several end-of-the-universe scenarios, and they are fundamentally different from one another. In one, everything slowly fades into absolute darkness and cold. In another, the universe tears itself apart in a fraction of a second, literally tears apart. Atoms, molecules, space itself. In a third, everything disappears instantly, without warning, at the speed of light, and you won't even have time to notice it. In this video, a full breakdown of each scenario, which one is most likely, and exactly when it will happen. First, the main thing you need to understand. The universe is expanding. That was discovered back in 1929. But in 1998, scientists discovered something nobody expected. The universe is not just expanding, it is accelerating. Every year, galaxies fly away from each other faster and faster. They are not slowing down, they are accelerating. That means there is some force pushing space from within. It was called dark energy. We do not know what it is. We cannot see it or measure it directly. We only know one thing. It makes up 68% of the universe's total energy. And it is what will determine how everything ends. Depending on what dark energy actually is, the ending will be different. Completely different. Scenario 1. The Big Freeze. This is the most likely ending according to current data. The universe keeps expanding. Galaxies drift so far apart that they can no longer see one another. Stars burn out one by one. New ones are no longer born because there is no gas left to form them. In 100 trillion years, the last star will go out. Only black holes will remain. But they are not eternal either, and this is where things get truly bleak. Stephen Hawking proved that black holes slowly evaporate. After an unimaginably long time, 10 to the power of 100 years, the last black hole will disappear, and absolute darkness will arrive. Absolute cold. Minus 273 degrees Celsius. Absolute zero. Not a single atom able to move. Not a single photon of light. Physicists call this the heat death of the universe, a state of maximum entropy where nothing more can happen. Ever. But that is the best-case scenario. Scenario 2. The Big Rip. Remember dark energy? Here is what happens if it keeps growing stronger. The expansion of the universe accelerates. First, galaxies pull away from one another. Then, stars within galaxies. Then, planets break away from their stars. Then, atoms are torn apart from within. 200 million years before the end, galaxies will fly apart. 60 million years before the end, star systems will disintegrate. 3 months before the end, planets will explode. 30 minutes before the end, stars will be ripped apart. Seconds before the end, atoms will fall apart. And space itself will tear in two. This is called the Big Rip, and according to some calculations, it could happen in 22 billion years. But this is still not the most terrifying scenario. There is a third scenario, and it differs from the first two in a fundamental way. Because in this one, we will not even have time to realize what is happening. It is called false vacuum. Let me explain simply. Quantum physics says that the space around us is not empty. It is a field, a quantum field with a certain energy level. We think this field is in its minimum energy state, at the very bottom. But what if it isn't? What if our vacuum is not the true minimum, but a false one? Like a ball stuck in a dip on the side of a hill. It looks stable, but the hill continues. At some random point in space, a quantum tunneling event occurs. The field drops into the true minimum energy state, and from that point, a bubble of new vacuum begins expanding at the speed of light. Inside that bubble, different laws of physics, different constants, a different reality. One incompatible with the existence of atoms, molecules, life, anything. The bubble expands at the speed of light. You will not see it coming, because it moves as fast as any signal of its existence. It will simply appear. And in that same fraction of a second, you will be gone. No pain, no fear, no awareness, just was, and then wasn't. And now, for the most terrifying part. This could have already begun, right now. At the other end of the universe, billions of light years from here, the bubble could already be flying toward us, and we would never know until the very last moment. Physicist Sidney Coleman, who developed this theory, when asked how likely it was, gave a short answer. He said, "Likely enough to think about." But let's talk scale. Not about what will happen to Earth or the solar system, about what will happen to everything. The observable universe is a sphere 93 billion light years across. Inside it, more than 2 trillion galaxies. In each galaxy, on average, hundreds of billions of stars. Around most stars, planets. On some planets, possibly life, intelligent life, civilizations, beings that also look at the sky and ask the same questions. All of it will disappear. Absolutely everything. Every star, every planet, every atom. Nothing will remain to show that any of it ever existed. No records, no traces, no memory. And here is what physicists have realized relatively recently. Even the laws we think are eternal are not eternal. The speed of light, the force of gravity, the mass of the electron. All of these are parameters of our particular universe. In another universe, there are different parameters. That means nothing is absolute. Nothing exists independently of conditions, including existence itself. Existence is not the norm. It is an exception. Temporary, fragile, random, and finite. There is one question physicists do not like to discuss publicly. If the universe is doomed, why do anything at all? Why build, love, create, search for meaning? If the ending is fixed and absolute. But here is what is strange. You are here right now, in this exact point in space, at this exact moment in time. Out of 10 to the power of 80 atoms in the universe, these specific atoms came together in exactly this way to create you. The probability of that is virtually zero. And yet, it happened. Maybe that is the answer, not to the question of the end, but to the question of meaning. The universe did not ask whether it should exist. It simply exists, brightly, chaotically, temporarily. Trillions of stars burn not because they have a purpose, but simply because they burn. And someday, they will go out. But right now, they are burning, just like you are. The last star will go out in 100 trillion years. You have time. The only question is, how will you use it? Or has the universe already decided that for you? And you just don't know it yet.